So, am I audible to all of you, students? Am I audible to all of you, students?
Yes, sir. Yes, sir.
Okay. Please mute. Please mute your mic.
Vibratory motion.
Can you hear the sound of the video?
There are
Can you hear the sound of the video?
from that few types we will study one by one.
Can you hear the sound of the video, students?
Vibration.
Yes, sir.
Okay.
Forced vibration.
So let us go with the free and forced vibration thing. Okay.
What is free vibration? When no external force acts on a body. After giving an initial displacement, then the body is said to be under free or natural vibration. Initial disturbance is given to body and system is left to vibrate without influence of external forces. The frequency of free vibration is called as this natural frequency. This also we have previously studied. Frequency of free vibration is called as a natural frequency. What is free vibration? When initial displacement or disturbance is given to system and system is now left to vibrate without influence of external force, then this type of vibration is called as a free vibration. The frequency of this free vibration is called as natural frequency. What is forced vibration? When the vibrating system is simultaneously or stimulated by external forces, then this type of vibration is called as a forced vibration. When the body vibrates under the influence of external force, then the body is said to be under forced vibration. The external forces applied to body is a periodic disturbing force created by unbalance in many times. Remember, the external force applied to body may be a periodic disturbing force created by unbalance. Many times it is due to unbalance only. Now, if the excitation frequency matches with natural frequency, there will be resonance occurring in the system. During this forced vibration only, resonance occurs. Due to external forcing frequency matches with natural frequency, there will be resonance. Remember this. This is regarding free and forced vibration. This we are going to study in detail what is free vibration, types of free vibrations once again. But this is basic free and forced vibration. Second, undamped and damped vibration. So, what is undamped vibration? When no dissipation of energy is there, this type of vibration is called undamped vibration. No dissipation of energy. What is damping? We have studied previously. Damping is resistance to vibration. That means no resistance to vibration is there due to dampers. At that time, this vibration is called as undamped vibration. That is, no resistance means no dissipation of energy. Now, system without dampers creates undamped vibrations. In many cases, the damping is negligible or very small. For still it is 1 to 1.5% only. In many cases, it is very small in case of undamped vibration. What is damped vibration? When there is a reduction in amplitude of vibration Over every cycle, the motion is said to be damped vibration. Dissipation of energy occurs there. That is, resistance to vibration occurs there. That is, reduction in amplitude occurs there. This type of vibration is called as a damped vibration. Vibration amplitude decays. The system with the dampers creates the damped vibration. Remember, the system with damper creates damped vibration. Understand what is undamped vibration and what is damped vibration. No dissipation of energy, and here dissipation of energy occurs in case of damped vibration. Next, deterministic and random vibration. Deterministic vibration, it can be described by implicit mathematical functions as a function of time. These are deterministic. That means we can find the magnitude of these vibrations. But in case of random vibrations, they cannot be predicted. The process can be described by statistical means, that is, statistical analysis. In case of deterministic vibration, vibration amplitudes can be determined, can be found easily. But in case of random vibration, the amplitudes of that vibration we have to find by statistical analysis. This kind of analysis is very difficult than that deterministic vibration. Now, example of that random vibration is earthquake. In that we cannot find exactly what is the magnitudes of these vibrations because it's randomly changing. That's why they are random vibrations. Understand deterministic and random vibrations. Next, types of free vibration. We have seen what is free vibration when there is no external force acts on body. After giving an initial displacement, then the body is said to be under free or natural vibrations. Now, types of these free vibrations are basically longitudinal vibration, transverse vibration, and torsional vibration. We will see it one by one. First is longitudinal vibration. When the particles of shaft or disc moves parallel to the axis of shaft, as shown in figure, then the vibrations are known as a longitudinal vibration. See in that diagram, if suppose one shaft and one disc is attached to that shaft and one end and at one end it is fixed, then consider the B is the position, initial equilibrium position of that disc. If we displace that disc at point from B point to C point, then release, then the vibration parallel to the axis of shaft are known as a longitudinal vibration. In this case, the shaft is elongated and shortened alternatively, and thus the tensile and compressive stresses are introduced alternately in the shaft. In this case, the shaft is elongated and compressed alternately. Therefore, tensile and compressive stresses are induced in the shaft alternately. Again, another example I can quote here as vibrations in the spring along with the mass. That is nothing but vibration in the spring along its length. Along its length or parallel to its length is called as a longitudinal vibration. Second is transverse vibration. When the particles of shaft or disc moves approximately perpendicular to the axis of shaft. Previously, what I have told you, parallel to the axis of shaft, vibrations are longitudinal. Perpendicular to axis of shaft, vibrations are transverse vibration. For example, consider one shaft and one disc attached to that shaft, and that disc has moved from B position to A position. It is perpendicular to shaft, approximately perpendicular to shaft, then release, then it will oscillate from A to B, B to C again, C to B, B to A again. That means this type of vibration is called as a transverse vibration. Now in this case, the shaft is straight and bent alternately, and bending stresses are induced in the shaft. Remember, for the gate purpose as well as for your exam purpose. During transverse vibration, alternate bending stresses are induced in shaft, whereas in case of longitudinal vibration, compressive and tensile stresses are alternately induced in the shaft. Example, vibrations in the strings of guitar. If you are using any instrument, musical instrument, then you can hear that in case of guitar, perpendicular to length of that strings, you are vibrating these strings so that the vibrations will be transverse vibration. Now, vibrations in the cantilever beam can also be the transverse vibration if you vibrate that cantilever perpendicular to its length. Third, torsional vibration. When the particles of shaft or disc moves in a circle about the axis of shaft, then this type of vibration is known as torsional vibration. See in that figure, there is one shaft and one disc attached to its one end. And that disc at initial position is at a B, suppose, and it is twisted towards A and release. Then there will be motion of the particles of shaft or disc in the circular manner about the axis. That is, it will twist and untwist about the axis of shaft. This type of vibration is called as a torsional vibration. In this case, the shaft is twisted and untwisted alternately, and the torsional shear stresses are induced in this shaft. Remember, here in torsional vibration, torsional shear stresses are induced in the shaft. Example, alternate twisting and untwisting of the shaft, like in this example, in this diagram. What we have studied in today's lecture, we have studied some basics of vibration.
बंद कर देता हूँ अभी, फिर थोड़ा बकूंगा किस बात है। So let me explain you. Students, you will be finding the link of this video in the chat box. So if you have to refer to this for further anything, you can just refer to it. Okay. So now let us discuss a little bit on the topic again. So can you see the PDF? Yes, can you see the PDF?
Yes,
Yes,
sir.
sir.
So did you understand the previous video a little bit? Free vibration, force vibration, then damping and all. Were you able to understand it?
Sir.
Yes. Okay. So if anyone has any doubt, they can ask me. Or else I'll move to the next topic now. So let us move to the next topic. What are the basic terminology in vibrations? So now, last classes we had discussed regarding oscillatory motion. You all know. Now, the study of vibrations is mainly concerned with the oscillating motion of elastic bodies and the force associated with them. Now, all the bodies possessing mass and elasticity are capable of vibrations. Okay. Most engineering machines and structures experience vibration to some degree, and their design generally requires consideration of their oscillatory motions. Now, the oscillatory systems can be broadly classified into linear or non-linear systems. So the oscillating motions are those motions which repeat after a certain interval of time. Okay. Now most engineering machines that are actually present, they what? They experience oscillatory motion, or you can say vibrations. The oscillatory systems can be characterized as linear or non-linear systems. Okay. So what is linear system first of? Linear system means the principle of superposition, it holds good. Okay. That means what? Can anyone say me what is principle of superposition?
The addition of all the individual forces.
Not force, but in vibration, what will be that? Now, okay, fine. In force system, it is okay, but in vibration system, how will you determine it? In vibration system, how will you determine it? Can you say me? Can you tell me? You are correct only. Just
Sir, I think addition
hmm,
of amplitude.
addition of amplitude. Okay, okay. Pretty good, pretty good. So how will you know that it is the addition of amplitude? Can you say me in a more simple manner? Suppose, let me give you an example. Why are all your friends giving attendances? This is not good, na? Every day I find out that some people just come and give the attendance. I will simply block the chat box from next time onwards. So suppose here this is one wave and this is another wave. So according to principle of superposition, the resultant will be the sum of, but in a particular point, suppose in this particular point, the resultant will be what? Sum of the displacement, this one plus this one. So that will be the resultant. Okay, so that will be the resultant. So in this way, you compute from principle of superposition. Okay. Now that means what? In linear system, the principle of superposition what? It hold good. Okay. Now in non-linear system, we are done with the linear systems. Now in non-linear system, what happens? The principle of superposition does not hold good. Okay. Now in linear system, the mathematical techniques that are available for their analysis, those are what? Those are well developed. Whereas in case of non-linear systems, the technique for analysis is what? Not well known, or it is difficult to apply. Now, with increasing amplitude of oscillations, all the systems try to tend to become what? Non-linear. Okay, so this is some of the basic differences. Okay. Now, as you have seen from the video also, the previous slides, there are two classes of vibration, free and force. Remember, But this free vibration takes place when a system oscillates under the action of forces which are present in the system itself due to initial disturbance, and when the externally applied forces are absent. So in free vibration, what happens? Suppose a body has some amount of vibration that are, or some amount of vibrating forces that are present initially because of certain initial disturbances. And
Sir,
बोलो,
suppose a car
मैं एक बार बोल लूँ,
is
ठीक है, उसके बाद पूछ
on
सकता है
a
तू। हेलो, तुम 2 मिनट रुक सकता है क्या? मैं इसको कंप्लीट कर लूँ।
ठीक है सर, ठीक।
हाँ, 2 मिनट रुको तुम, उसके बाद मैं कंप्लीट करके तुम पूछना, ठीक है। तो क्या होता है, ओ, इन फ्री वाइब्रेशंस the body has certain amount of forces present in itself due to certain initial disturbances, and suppose there is no external force that is being applied on the body, then we get what? Then we get the free vibration. Okay, पूछो अभी क्या है पूछना। हेलो।
सपोज सर, हेलो, सुनाई दे रहा?
हाँ, सुना दे रहा है, पूछो। तुम
हेलो।
अपने अब सुना दे रहा है, पूछो पूछो चल।
A car is moving on a highway, plain highway, and vibration caused by that car is free or force?
फोर्स होगा, कार तो भी मूव कर रहा है ना।
Why, sir?
कार मूव नहीं कर रहा है क्या? कार अगर मूव कर रहा है
Extra.
तो एक्स्ट्रा फोर्स
Yes,
अप्लाई हो
sir.
रहा है कि नहीं उसके ऊपर, इंजन का। इंजन ही कार को मूव करवा रहा है ना एक्स्ट्रा फोर्स को, तो एक्स्ट्रा फोर्स अप्लाई हो रहा है कि नहीं है? समझा?
Okay.
तो इसलिए फोर्स ही होगा, समझा? हेलो, समझा नहीं?
We can only consider initially जो vibration causes करता है उसको we can say that it is an external
एक्सटर्नल नहीं, फ्री वाइब्रेशन।
free. Only
मतलब
initially force जो
हम्म
vibration cause करता है उसके बाद
नहीं,
वो जो vibration है free vibration.
हाँ, और अगर कोई एक्सटर्नल फोर्स लग जाए तो फोर्स होगा, समझा? सपोज मैं एक बार एग्जांपल देता हूँ तुमको। तुम्हारा सपोज एक बॉडी मतलब एक बॉडी एक जगह पे खड़ा हुआ है, तो इट विल हैव सम नेचुरल वाइब्रेशन। ऑलवेज रिमेंबर दैट बॉडी का कुछ थोड़ा बहुत भी नेचुरल वाइब्रेशन रहेगा, ठीक है? तो वो फ्री फ्री वाइब्रेशन होगा, समझ रहे हो? सपोज समझ रहे हो मैं क्या बोल रहा हूँ? हेलो।
Yes, sir. Yes. तो सर in pre-vibration there is a word used initial disturbance. What is this, sir? Hello.
हेलो, एक बार फिर से पूछो तो, मुझे सुना ही नहीं दिया ने।
In definition of the pre-vibration, there is a word used initial disturbance. What is that, sir?
देखो, इनिशियल डिस्टरबेंस मतलब सपोज तुम एक पेंडुलम को हाथ से थोड़ा मूवमेंट कर दिया, फिर पेंडुलम को जब तुम लोग रस्सी पे लगाते हो तो उसका कुछ इनिशियल डिस्टरबेंस होता है कि नहीं? होता है कि नहीं?
यस सर।
तो उसको तुम
यस
लोग
सर।
क्या बोल सकता है? इनिशियल वाइब्रेशन। ठीक है।
सो सर, तो वो दैट आई थिंक फॉल अंडर फोर्स वाइब्रेशन, क्योंकि इनिशियल के लिए तो उसको तो
अरे तुम
थोड़ा तो
कंफ्यूज क्यों
हिलाना पड़ रहा है।
तुम कंफ्यूज क्यों हो रहा है? इनिशियल का बारे बात बात सुनो ना, इनिशियल वर्ड के बारे में क्या बताएं? इनिशियल वर्ड मतलब क्या है? जो पहला वाला ऑसिलेशन है। एक पेंडुलम को जब तुम हाथ में लग के बैठा है तो उसको इनिशियली थोड़ा मूवमेंट देना पड़ेगा ना। बाद में अगर फोर्स अप्लाई करता रहेगा तो बार बार घूमता रहेगा, लेकिन इनिशियली एक फोर्स जब अप्लाई होगा, इनिशियल जब देगा फर्स्ट टाइम, तो उसके लिए जो वाइब्रेशन होगा वो फ्री है। समझा?
मीन सर, व्हेन एक बाइक जब डाउन डाउन में जाएगा, गाड़ी को ऑफ कर दिया, न्यूट्रल में चला गया,
अरे
इंजन से काम नहीं कर, देन वी कैन कॉल ऐसे
इतना दूर तक मत
प्री।
सोचो। बाइक को स्टार्ट किया ना तुम।
नो।
सुनो, मैं बोलता
यस
हूँ,
सर।
सुनो। बाइक को स्टार्ट करने से इंजन थोड़ा वाइब्रेट नहीं होगा क्या? हाँ।
हाँ।
लेकिन इंजन का क्या होता है, वो थोड़ा फोर्स अप्लाई होता है कि नहीं? वो थोड़ा मैकेनिकली होता है ना। मैं तुमको सिंपल एग्जांपल दे रहा हूँ एक
सपोज हम लोग
पेंडुलम
तेल
का।
मतलब।
एक पेंडुलम का तुमको एग्जांपल दे रहा हूँ, समझा? तो एक पेंडुलम जब इनिशियली वाइब्रेट करेगा तो उसको फ्री वाइब्रेशन बोलते हैं। वही है। ओके।
ओके बाय।
और एक देता हूँ तुमको, और एक एग्जांपल देता हूँ अच्छे। सुनो, वो ये बताया ना, स्विंग झूलना। झूलना पता है कि नहीं? हेलो।
हाँ हाँ।
स्विंग स्विंग, यू
यस सर।
अंडरस्टैंड
यस सर।
दैट? तो
यस सर।
उसका फ्री वाइब्रेशन कौन सा होगा बोलो तो? एक-
जी।
हम्म।
सॉरी सर, क्या बोला?
उसका फ्री वाइब्रेशन कौन सा होगा बोलो तो?
प्री वाइब्रेशन,
हम्म।
जुलना को धक्का देने के बाद जो वाइब्रेशन होगा वो तो
हाँ,
प्री
वो
वाइब्रेशन है।
अगर तुम जुमला में बैठा है तो कोई तुमको पीछे खींचेगा ना, है कि नहीं? हेलो, पीछे खींचेगा ना? तो तुम पीछे
यस
आने
सर।
के बाद उसके बाद फ्रंट में जाने के लिए शुरू करेगा ना, तो वो फ्री वाइब्रेशन है।
यस
बात
सर।
समझ में आया?
ओके सर। मतलब सर, मतलब we हम लोग उसको एक मतलब वाइब्रेट होने का फॉर्म में ला सकते हैं, लेकिन एक्सटर्नल फोर्स नहीं दे सकते हैं।
हाँ। फ्री वाइब्रेशन मतलब क्या? वो अगर
जी।
झूलना को लगाएगा, तुम पहले एक बार खींचने के बाद वो तो अपने आप ही झूलता रहता है ना, है कि नहीं?
हम्म।
तो उसको फ्री कहता है।
हम्म।
समझा?
ओके।
समझा? समझा कि
सही
नहीं?
सर।
इज इट क्लियर?
सर
इफ यू हैव एनी डाउट्स यू कैन आस्क मी।
सर सर
पूछो। Why your friends give the attendances
सर
before?
अप एंड डाउन
Up and down? Quoi?
सर द अप एंड डाउन ऑसिलेटरी मोशन इज कॉल्ड longitudinal vibration.
Hmm. Hmm. Hello. Hello.
सर
Hello.
सर सर
Quoi? Funious one, sorry. Yeah, please say. I'm hearing.
सर এইটো হয় না স্যার আপ এন্ড ডাউন অসিলেটরি মোশন ইজ দি longitudinal vibration.
Yeah, you can say that. You can say that in that manner.
Okay, sir. Okay, sir.
Okay. Can you tell me why your friends give
Yes,
the
sir.
attendance? Why your friends give the attendances so before, so early in the from the beginning of the class only? Some people just they have only one more give the attendance. I won't be considering these attendances. If you have any doubt, you can ask me.